Ladies and gentlemen, good day and welcome to another session of the Nambane Academy. Thank you very much for the support and for you to subscribe, and remember, tell a friend so that we can increase our numbers and create a better family for everyone that is now doing physical sciences. So remember, in the description I've also included the link to our website where you can find all previous question papers from different provinces, the ebooks, as well as the virtual laboratory that we've created through VLabs, so you can be able to perform certain experiments on the website as well. So it's an initiative that we are moving into, trying to incorporate ICT with our caps. So with that being said, let me not waste your time, and we are busy with a series of revision videos. So there are videos also under the electrolytic cell. Kindly watch that, but now the focus on this one is a galvanic cell. So now let's get straight into it without wasting any time. An electrochemical cell is set up using aluminum rod and a gas X. So we are told that now this one is a gas, and they say now the initial EMF measured under standard condition is 2,89 volts. So the first question here says now at 8.1, state the conditions under which the cell operates. So at 8.1.1, at 8.1.1, when we give the conditions, we can not only say it's temperature, it's pressure, and it's concentration. We cannot now just say that. The examiner is interested in us giving the exact values of each. So this one will be now 25 degrees, and pressure will be 101,3 kilopascal, and this one will be just equals to 1 mole per decimeter cube. So you actually get a mark for the correct value together with the correct SI unit. So this will be now an easy 3 marks for one to get, but it's critical to understand these standard conditions of which a galvanic cell operates with. So it comes in and out. It's one of the questions that is your level 1 type of a question. So just ensure that you fully know and be able to give the correct values thereof. Then at 8.1.2, use the calculation to identify gas X. So one will ask, when I look into my equation, I can easily see that the equation I have is this one. And now this is in our formula sheet. It says E cathode minus E anode, or E reduction minus E oxidation. And then it says E oxidizing agent minus E reducing agent. So what does this say to me? It says when I go now to my table 4b, when I look into my table 4b, which is a table of standard reductions, when I look above aluminium, here is my aluminium. When I look above the aluminium, I don't see now any gas. So what does this say to me? It says now in a principle of us using the C method, where we say the above one is oxidation and then the one below is reduction. One can easily see that aluminium is there at the top and our X should be here at the bottom, because when we look at the table of standard reductions, there is no gas at the top. So it basically says when we use now our C method, we are in a position of saying the one that is at the top will undergo oxidation and the one at the bottom will undergo reduction. How does this assist me? This assists me in terms of knowing where to place the X in the formula and where to place now aluminium in the formula. So I'm going to write down the formula, which is now E naught is equals to E reduction minus E oxidation. And remember, you must write the formula as it is appearing in the formula sheet. Don't come now with any other formulas, your E rate, E ox. That one will not be given a mark for that. Write the formulas as they appear now in the formula sheet. So we are given that the E naught is 2,89, and now I know that this should be X minus E of oxidation, which is now from the table, it's negative 1,66. Then I can do the mathematics thereof, and the mathematics is 2,89 minus 1,66 is equals to X, and then X is equals to plus 1,23V. Now that is the final answer that I get, but did it assist me in terms of answering the question? Let's go back to the question. They say now use a calculation to identify X, which is now a gas. So I have a table here. I have 1,23 there and 1,23 there. But when I check the one at the top, I don't have any other gas. Water can be in a form of a water vapor, but I am not now in a position of saying, is this in a state of a gas or not? So once I am not told, then I cannot just assume. I can easily look into this one of oxygen, then that one will be the one that we use, and then the only gas there, it's now oxygen. So we can easily say X, it's now O2, or one can easily say it is oxygen. So this is now the best way of fully trying to look into this specific question. We used the table, and also we used now the formula that we have in the formula sheet. So this will be your nice easy 5 marks. That will be now one for writing the correct formula, one for the substitution there, and one for the substitution of 1,66, one for the final answer, and one for concluding that it is now oxygen, and this becomes our 5 marks. Let's further move on. At 8.13, write down the formula of the reducing agent. So I have seen most of people confusing all this. So the cheat that I have is, once we have identified that where is oxidation taking place, it is taking place at anode, and now the substance that is undergoing oxidation is our reducing agent. So I am basically using the cheat sheet that is now in the formula sheet to say, once I have identified which substance undergoes oxidation. I can associate that now with an electrode, which is an anode. I can associate that now with a substance that we call now a reducing uh, agent. So it is easy because we said now aluminium undergoes oxidation. Definitely then aluminium must be our reducing agent. So that is from the table and also using the formula sheet that is given. So at 8.14, write down the half reaction that takes place at cathode. That one is easy because we have identified that oxygen is the gas X that has been used. Then we can just write our half reduction that we found in the table, which is just now O2 plus 4H plus 4 electrons, one arrow. It gives us now 2H2O. So this becomes our reduction half cell. So with this being said, everything now becomes nice and easy because the question that follows thereafter, it says now write down the cell notation. But before I answer that one, I want us to have the net cell. Let's have the net cell, and having the net cell is I need now to have the aluminium half cell. So for the aluminium half cell is just aluminium giving us aluminium 3 plus now 2 electrons. So I must just multiply everything by 2 such that the electrons can balance. So the net cell will be something like, sorry, let's move this. Let's move this a little bit lower. And then we say now, this one is our oxidation half cell. Then the net cell will be now easy. And then we have our 2 there. Will be easy for one to say. Then I'm going to have the 2 aluminium plus O2 plus 4H plus. That will give me now something like 2H2O plus now 2 aluminium 3 plus. So from the net cell, the key idea is I want us to get to the cell notation. So from this, we are just going to do drag and drop. How does our cell notation look like? Our cell notation is face border, salt bridge, face border, and another face border. So let's see, this side we say is now it's the side related now to oxidation, and this side here is the side related now to reduction. So with this, one can easily see that we are going now to have aluminium that gives us now aluminium 3 plus, and we have our salt bridge. Then in the salt bridge we have now our O2. After the O2 we have now the H plus, but we still have the H2O liquid there. Then we have H2O liquid, but what is the catch? The catch is I am working with a gas, so I need to have that platinum for me to increase the surface area or the conductivity of the gas. So this whole side here will represent now the reduction. Why add a PT? Because now we are using a PT in terms of we are working with a gas. Add PT when working with gases. It's always important because it increases now the surface area or the conductivity of the gas thereof, in terms of ensuring we maintain the cell neutrality and everything has been now conducted accordingly. So it is always important to ensure that once you have a gas, then you must have your PT at the end. So when looking at this, it's just an issue of one understanding what does the other side or each side of the cell notation basically means. So one will be given a cell notation, and also from the cell notation one must be in a position of interpreting that cell notation. So like I did say earlier on, once you are able now to identify and pick up which one undergoes reduction, which one undergoes oxidation, everything else becomes easy for one to follow, and everything now in this instance becomes nice and clear. So let's answer the last question, which is now 8.2. So at 8.2, I'm just going to put it here at 8.2. They say, which container, zinc or copper, will be more suitable to store an aqueous solution of nickel ions, that is nickel 2 plus. Refer to this table of standard reductions to fully explain in terms of the strength of the reducing agents. So with this one, we need now to look at the table. So I'll want you now, when you watch this video, kindly have a table 4b next to you, such that you can easily understand where all this information comes from. So when looking into the table, Cu is a weaker reducing agent than nickel, and will not reduce Ni2 plus. Then we check now the zinc. Zinc is a stronger reducing agent than nickel and will reduce nickel 2 plus. What does this say now to us? This says to us now zinc will be oxidized. Zinc will be oxidized to zinc 2 plus. And that is not what we want, because if it is oxidized, it means now we are going to have a reaction thereof. So the final answer here allows us to say copper is now the correct answer. So the information, it's now in the table of standard reduction potentials. So don't forget to subscribe, tell a friend, and from me to you, thank you very much. Keep on watching. There will be more content coming your way. So from me to you, thank you very much and have a lovely day.